Hello everyone, welcome to the second part of this lesson, graphing functions with um, domain restrictions manually. If you haven't seen the first part, just click the link below and so that you would understand the key concepts. But if you already watch it, it's also good to recall or review the key concept. Now let's go straight to the model problem. If we are going to graph, p of x is equal to negative x squared plus 4 with the domain restriction. This is the domain restriction right there. Oops, that's very efficient. Negative 1 less than or equal to x. X is less than 3. Now, we're gonna deal with it like this later. But let's complete this table first. Again, if you know how to use the Desmos, or if you have a graphing calculator that can generate table, that would be great. However, in this video, we're gonna do the old school, which is substitution. Now, if you notice, my values for x are from -1 to +3. I took these numbers from the restrictions. Alright, now as I have mentioned in first part of this lesson, it's always easy to use the positive numbers or value of x to substitute so that we can easily, that's the easiest way to complete this table. Alright, let's do +3 for x. So p of 3 equals negative, I'm going to put the parentheses around 3 as the value of x squared plus 4, which is, now this is +3 squared, meaning +3 times +3 is 9. Now notice that there's a negative in front of 9, we need to write it there, plus 4. So -9 plus 4, that's -5. So this is -5. Let's do the second one. So if I'm going to take this off, go. So let's have, instead of 2, let's take the -1. Because usually the students mess up with negative numbers every time we substitute. Let's do that together. So again, we are putting -1 inside the parentheses, but still we need to keep the negative outside the parentheses because that's originally there. Alright, so -1 to the second power, meaning -1 times -1 is +1, and then we keep that negative in front of 1, plus 4, which is +3. Right, so this is +3. After repeating the same process of substitution, we were able to come up with the values of p of x. Okay, now we're ready to graph the coordinates. Let's start from right to the left. +3, -5. Alright, if I'm at the origin, this is 1, 2, 3, 5 is 1, 2, 3, 4, 5. Again, every time you're graphing a function with constraints or domain restriction, always use an open circle for now, because it's easy to bubble it in later if you need to. But if you already bubble it in and then you realize it should be an open circle, then it's gonna be a mess. So 2, 0. So we have 1, 2, and 0. It's on the x-axis. +1, 3 right here. 0, 4, 1, 2, 3, 4. And -1, 3, -1, 3. There we go. This is the graph. These are the points corresponding to the table that we generated. As I have mentioned before, every time you sketch, you need to use a pencil first. right? So your parabola, since it's a quadratic, I know that it's a parabola graph. Your parabola would look like this. Now, do I have to put an arrow here? No, because of that restriction. Do I have to put an arrow here? No, because of that -1 restriction. Now, what do? Do we keep this as an open circle? Based on this, it's -1 less than or equal to x. Since there's a negative symbol, that means we need to bubble that in. It's a closed circle. How about on the +3? +3 is right here. That circle is an open circle. Now we're ready to trace the graph of this function -x² + 4 with a given restriction. There you have it.